All right, so this is part 2 of the Unit 4 review sheet. All right, so we're starting here with number 14. Which graph shows a quadratic function with 2 imaginary roots? Now, first thing I want to point out, a quadratic function is just a parabola. Okay, so it either looks like a smiley face or a sad face. And a quadratic function can have up to 2 roots. Okay, real roots intersect the x-axis. So right here, letter A has 2 real roots. Letter B also has 2 real roots. Letter D has only 1 real root. Now, if we look at letter C is the only one that does not intersect the x-axis. So letter C is the one that has 2 imaginary roots. Okay, imaginary roots do not intersect the x-axis. So letter C is the answer. Okay, number 15. Using the method of completing the square, they want us to express that equation in this form right here. Okay, so the first thing we want to do is we want to subtract 11 from both sides of the equation. Okay, we want to move this number over. We want to get just these 2 terms right here by themselves on the left-hand side of the equation. Okay, and the reason we do that is so that we can put our own little number here, right? We want to create what we call a perfect square trinomial. Now, in order to do that, we look at our middle term here, right, this 3. And we want to take half of that number. I'm going to do this off to the side. So I'm going to take half of 3, which means we divide it by 2. And then we're going to square that whole thing. So when we do, the numerator squared becomes 9, and the denominator squared becomes 4. So 9/4 is the number that we're going to add to both sides of this equation. Okay, remember, we have to add it to both sides to keep it balanced. Whatever you do to one side of the equation, you have to do to the other. Okay, so now what we're going to do is we are going to factor the left side of the equation. Okay, so I'm going to set up 2 sets of parentheses with an x and an x, right, since this is x squared. And if I want to come up with 2 numbers that add to 3 and multiply to 9/4, I mean, that might be tricky, but remember the trick. It's always half of this number, right? So half of 3 would be 3/2. So I'm going to add 3/2 within both parentheses. Okay, so 3/2 plus 3/2 is 3, and 3/2 times 3/2 is 9/4. But the trick is whatever number goes in here is always half of your middle term. Okay, and then on the right side of the equation, if I add negative 11 plus 9/4, so that'd be negative 44/4 plus 9/4, that would give me negative 35/4. All right, so I know that this right here, since I have 2 of the same factor, I could just rewrite that once. With a square on it, and I'm going to bring down my negative 35/4. Now, normally with completing the square, we would continue on, but they just wanted us to take this equation and write it in this form. So don't I have x minus some value being squared? Well, this is x plus some value being squared, but isn't minus a negative the same thing as a plus? It really doesn't matter what sign you have in here when you want to get it in this form. And then I want some number all by itself over here, which is what I have. So this is our answer. This is the form that they were looking for. Okay, so number 16 wants us to solve this equation by completing the square and by using the quadratic formula. I mean, so since it's the same equation, no matter which method we use, we should get the same answer. Okay, so let's start with completing the square. Now, if you remember, we need to get this to be a 1x squared. So whenever there's a number in front of the x squared, we're going to divide everything by that number. So in this case, we're going to divide everything by 4, leaving us with x squared minus 4x. And I'm just dividing every number by 4. And then equals negative 144 divided by 4 is negative 36. Okay, so what's nice about this is we already have our number on the other side of the equation. So now we can just basically jump right into completing the square. right? We want to create a perfect square trinomial. And in order to do that, we take half of this middle term and square it. So I'm just going to do this out loud. Half of negative 4 is negative 2, and negative 2 squared, right? Negative 2 times negative 2 is positive 4. So I'm going to add 4 to both sides of the equation. Okay, and then from here, we're just going to factor this side of the equation. So if we factored this, we would wind up with x minus 2 times x minus 2, which I'm going to just write once with a square on it. Okay, remember to find the number that goes here, it's just half of your middle term. And then on the right-hand side of the equation, we're going to just add those two numbers together. Okay, so now to get rid of a square, we know we need to take the square root. So I'm going to take the square root of both sides. So on the left side of the equation, a square and a square root cancel each other out, so I could bring down the x minus 2. And don't forget, this square means we have two solutions, so we're going to have plus and minus. And now we have to simplify our radical. Now we know whenever we have a negative under the radical, right, the square root of negative 1 is I, so I'm going to bring out an I. And then let's break down the radical 32. So the biggest perfect square that divides evenly into 32 would be 16. So I'm going to break this down into radical 16 times radical 2. Okay, you want to find the biggest perfect square that divides evenly into 32 and put it here. And then since 32 divided by 16 is 2, I'm putting the leftover 2 right here. All right, we know that the square root of 16 is 4. So I could rewrite this as plus and minus 4i radical 2. All right, so let's do that. Let's rewrite that as plus and minus. This becomes a 4i radical 2. And then we could just bring down the left side of the equation. All right, we're almost done. All we have to do is get this x by itself. So in order to do that, wouldn't we add 2 to both sides of the equation? So when I add 2 to both sides of the equation, I'm going to be left with an x on the left-hand side. And this negative 2 moves over here and becomes a positive 2. So I'm going to have positive 2 plus and minus 4i radical 2. Okay, and that is my answer. All right, now let's also do it over here using the quadratic formula, and let's see if we get the same answer. We should, right? Because it's the same equation. Okay, so we know in order to use the quadratic formula, we need to have this side, or one side of the equation equal to 0. So I took the negative 144 and added it to the left side, so I moved it over here. Now, I could do the quadratic formula with these numbers, but we know they're all divisible by 4, so let's just divide everything by 4, and that's going to make our life a lot easier, just because the numbers will be smaller. All right, so when we divide everything by 4, this is what we get. Okay, so we know that, I'm just going to do this off to the side. We know our a is equal to the number in front of the x squared term, which is 1. The b is equal to the number in front of the x term, which is negative 4. And the c is equal to the number hanging out all by itself at the end there. Okay, now when we do the quadratic formula, this is an equation, right? We're rewriting this equation in a form that helps us solve for x. So we have to write x equals. All right, so x equals negative b, so it would be positive 4, plus and minus the square root of b squared, so negative 4 in parentheses squared, or if you prefer to just write 16, you can. That way you don't have to worry about the parentheses. And then minus 4 times a, which is 1, times c, which is 36, over 2 times a, so 2 times 1. All right, so that gives us x equals 4 plus and minus. All right, so you have to just kind of figure out what this is equal to underneath the radical. So 16 minus 4 times 1 times 36 gives us negative 128. Okay, and that's going to be all over 2. All right, so we have to simplify the radical. I'm going to do that off to the side here. So let me do that right over here. Okay, so first thing, because we have a negative under the radical, we know we're going to have an I in our answer. And then if we break down the radical positive 128, I mean, it should jump out at you, right? If you divide this by 2, that would give you 64. And isn't 64 a perfect square? So I'm going to put 64 here and 2 there. And since the square root of 64 is 8, I'm going to cross this off and make it an 8 and bring down the I after it. So we have 8I and then radical 2. Okay, so let's go back to our problem here. So x equals 4 plus and minus. We're going to replace that radical negative 128 with 8I radical 2. Okay, we have that whole thing over 2. All right, so now let's split this up into a plus and minus, so plus bi form, and then we'll simplify. All right, so we'll have x equals 4 over 2 plus and minus 8I radical 2 over 2. All right, so let's simplify. Well, 4 divided by 2 is just 2, so we have 2 plus and minus. And then isn't 8 divided by 2 just 4? So this would become 4I radical 2. And look at this. My two answers match up. So that kind of checks itself. If not, I would probably use the store button in my calculator and type in 2 plus 4I radical 2, store it as x, and then come back up here to the original problem and type in the left-hand side of the equation and see if it gives me negative 144. It's always a good idea to check. And we know that whether you're using completing the square or the quadratic formula, if the answer with the plus checks, then the answer with the minus sign has to check, right? Because the plus and minus is built into the formula. All right, number 17. If a solution to this equation is expressed in a plus bi form, what is the value of a? All right, so first thing, let's distribute the 2 into the parentheses. So 2 times 2x is 4x, and 2 times negative 1 is negative 2. Okay, so now, I like to have a positive leading coefficient. So rather than subtracting the 5x squared over and having a negative, I'm actually going to move these two terms. And at this point in math, you don't have to write minus 4x and then plus 2. Just, you can move it, right? So basically, on the right-hand side of the equation, I'm going to bring down the 5x squared. If I move this 4x over to the right-hand side, it becomes a negative 4x. And if I move this negative 2 over to the right-hand side, it becomes a positive 2. Okay, I'm going to bring down my equal sign. And then since there's nothing left here, right, I moved it all over and changed our signs, I put the 0. And I know some of you like to have the equals 0 on the right, so if you prefer to erase this and move it over here, go for it. Okay, you could do completing the square, you could do the quadratic formula. I personally am going to do the quadratic formula because you would have to complete the square, you'd have to divide by 5. And, then you're going to have fractions within. It's going to be more of a mess. So, and plus, I already got this set equal to 0, which is what we do with the quadratic formula. So I'm just going to use that. All right, so I'm going to have x equals. Now, just recall the a is 5, the b is negative 4, and the c is 2. Okay, and you have to write x equals. If this is an equation, you have to keep it an equation. And believe it or not, this equation that we're about to write is equivalent to the one above. It's just with the x all by itself on one side of the equation. All right, so x equals negative b. So positive 4 plus and minus the square root of b squared, so negative 4 in parentheses squared, minus 4 times a, which is 5, times c, which is 2, and that whole thing is over 2 times a, so 2 times 5. And just a reminder, if you're squaring a negative, you need these parentheses. Without the parentheses, you get a different value. All right, so x equals 4 plus and minus. All right, so then we got to figure out what negative 4 squared minus 4 times 5 times 2 is equal to, which would be negative 24. And we're going to put that whole thing over 2 times 5, which is 10. All right, so I'm going to simplify the radical negative 24 off to the side. We know that if we have a negative under the radical, right, that's going to come out. The square root of negative 1 is I, so it's going to come out as an I. And if you break up the radical positive 24, the biggest perfect square that divides evenly into 24 is 4. So it's going to be radical 4 radical 6. All right, and since the square root of 4 is 2, that becomes 2i radical 6. Okay, so this crosses off and becomes a 2. Bring down the I, and then we have radical 6. Okay, so we have x equals 4 plus and minus 2i radical 6 over 10. Okay, so let's split this up into a plus bi form, and then we'll simplify. So we have x equals 4 over 10, and then plus and minus 2i radical 6 over 10. And then when we simplify, 4/10 simplifies to 2/5. And then 2/10 simplifies to 1/5. So we have 1i radical 6 over 5. Okay, now the way that this is written, first thing, you do not need that 1 in front of the I, so if you prefer to erase that, you can. And then the other thing is, I'm going to just kind of come back up to the question. They said that if this is expressed in simplest a plus bi form, what is the value of b? So b is going to be the number in front of the I. So I'm actually going to take this I right here, and I'm going to move it to the end of our fraction. I'm going to rewrite this as 2/5 plus and minus radical 6 over 5i. And the only reason I did that is because I wanted us to see this would be our a, this would be the b, and this would be the I. They wanted us to find the value of b, so b would be equal to radical 6 over 5. Okay, that would be our answer here. Okay, number 18. Given x is a real number, write the expression in simplest a plus bi form. Okay, so we have a binomial times a binomial, so let's double distribute. So x times 3 is 3x. X times negative 2xi would be negative 2. X squared I. Okay, then 2i times 3 would be 6i. And 2i times negative 2xi would be negative 4xi squared. Okay, and then let's just bring down this plus 2x squared I at the end. Okay, so we never want to leave exponents on an I. So we all know this, right? I squared is equal to negative 1. So if I cross this off and make this a negative 1, wouldn't negative 4x times negative 1 be equal to a positive 4x? Okay, so this term right here becomes positive 4x. All right, I'm just going to bring everything else down, and then we'll worry about combining our like terms. Okay, so let's see. So first of all, if you notice, the negative 2x squared I and the positive 2x squared I cancel off. And then when we combine our like terms, we can combine the 3x with the 4x to give us 7x, and just bring down the plus 6i. Now, keep in mind, it does have to be written in this order, because when they say a plus bi form, they want the term with the I at the end. Okay, so this right here is our answer. Okay, and then finally, number 19. Given I is the imaginary unit, which expression is equivalent to this? All right, so let's just start off by distributing the 5i into the parentheses. So 5i times 2x would be 10xi. And then 5i times 3i would be 15i squared. Okay, and then we have minus x times, well, isn't the square root of negative 9 3i, right? The square root of 9 is 3, and the square root of a negative 1 is I. So that would be 3i. Okay, so we have 10xi. Now we know that I squared is equal to negative 1. So positive 15 times negative 1 would be negative 15. And then I'm just going to rewrite this as negative 3xi. Number comes first, then the variable, and the I always comes at the end. All right, so when we combine our like terms, we have 10xi and a negative 3xi. So that's going to give us 7xi. And usually we write it in a plus bi form, so the term with the I comes at the end. So I'm going to take this negative 15 and put it in front of that. Which means, since this was a positive term, I need to put a plus sign here. Okay, so basically I brought down the negative 15, and then 10xi minus 3xi is positive 7xi. So let's see, what does that match up with? Choice 4.